Then I'll apply an external force. An external force will be applied, and these are the normal reaction. This will be weight, and there's the direction of friction. If you see in the books, no, so they define one quantity called as the angle of friction. That one. This is called like a angle of friction, where theta is called as angle of friction here. Then the total contact force. What do you mean by total contact force? The contact force, the total. So here, so if you see that both normal reaction as well as the friction, there'll be contact force that will be acting here. Now, as I keep on increase the applied force here, then if applied force is less than limiting friction, so what is the nature of this friction? Will be static in nature. Then the contact force, what we can write as n square plus f square. Then as increase the applied force. So what is FC? FC you call it as the contact force. This is called a contact force. So as I keep on increase the applied force, we know the as we keep on increase the applied force, the friction will also increase, will be static. It gradually the value of that increases. And at one specific value of the applied force, the friction will be limiting. The maximum limit friction, the maximum static friction is called as a limiting one. Then at that particular thing, so I will. So what is the maximum value of contact force? Similarly, we can write here also. Fc is equal to n square plus mu s into, or say like this will be, you call Fl. What is the limiting friction? Limiting friction should be equal to mu s into n, which is equal to mu s mg, where a minus mg equal to 0, as usually you know. So this should be n square plus mu s n whole square. So this should become n into 1 plus mu s whole square. This is the maximum value of contact force. When the block is about to slip, at that instant what happen? I'm just asking the contact force here. Here what happen? Disturbance in my voice, huh?
No, sir, it's clear.
Clear? Huh?
No, sir.
Yes, sir, clear.
Check from your side. Huh? Let me check once. Yeah. Okay, this should be the contact force. So here now, let's go for the triangle, that one. So where this is the normal reaction, and this is the limiting friction, and there's a contact force. No, this, if you redraw this, n bar, shift this limiting friction here. And this is the contact force. This is called as theta. You can give any symbol. I'm just bringing theta. So what is tan theta now? Tan theta equal to FL by N. What is FL? Mu s N. For if the applied force less than, if the friction acting static friction, then the angle made by the contact force with the vertical, you should not call that angle of friction. When the frictional force acting is equal to limiting friction, then the angle made with the contact force with the normal contact is called as angle of friction. So when the block will shift, when theta greater than tan inverse of mu s, will I agree? When the block will not shift. So like this we can analyze. At other applications is very important, but at our level now we don't take much help of this. Just have an idea. So what is the angle of friction? You have to define the angle made by the resultant contact force, the normal contact. Both normal reaction and friction are called as contact because they are existing due to contact here. That's why the resultant contact force will call the resultant of N and F is called as the contact force. Both N and F, they are called as contact force. They ask you to find the contact force, means the resultant of N and F is what? Contact force here. Okay, now you should, when the friction acting is static, you should not call angle, you should not define angle of friction. When to define angle of friction? When the friction acting is limiting, then the angle made by contact force, the normal, we should define as angle of friction. Got the idea, no? This is the one condition we'll put in.